Greetings and welcome, ladies and gentlemen. This is Mr. Waddy. We're talking about section 11.2, and we're talking about areas of circles. And does anyone know what this little slice is called? It's not a triangle. It's not a pizza. It's not a slice of a circle. Like that is called a sector. We're going to talk about that today. So we're going to talk about areas of sectors. So you can divide a circle into congruent sections and flip it and fold it and all sorts of cool things. And it turns out if you take those sectors and interlock them, you get a parallelogram roughly with a height of r and a width, which is half the circumference, which is pi r, and the area will be pi r squared. And if you subdivide this infinitely many times, this will become a rectangle, and the area would be exactly pi r squared, congruent to the previous area of the circle. Wow, what an amazing world we live in, friends. So the area of a circle formula, get ready to have your minds blown, is pi r squared. So you guys should highlight that, put that on note cards. You should think about circles all day. And here we go. Let's put this to use. And here we go. Example 1. Find the area of a circle with radius 2.5. That's just a matter of plugging it in the formula. Area would equal pi times 2.5 squared. According to PEMDAS, you do exponents before multiplication. So I've got to square the 2.5. What's that, 4.25? 6.25. Crazy, Mr. Waddy. So that's equal to 6.25 pi, which is approximately multiply by pi, and I'd get 19.635 roughly. All right, so that's the area of a circle, and that would be measured in centimeters squared. All right, so that is area measured in square units. Circumference, notice the distance around a circle was measured in linear units. It is not an area with square units, but area is asking the question, right, how much space is on the interior of said circle. Now, classic algebra problem, what if I don't know the radius, but I knew the area? Or what if I know the diameter, or I want the diameter, but I know the area? You can plug in what you know, solve for what you don't. So, pi r squared is equal to 113.1. How could I solve that for r? It's being multiplied by pi. So divide both sides by pi, and then I'll root both sides. That sounds right. Root. 113.1 divided by pi. Rutabaga. I get 36.0008. We'll call that 36 for the sake of our accuracy here. Root both sides, plus or minus. Don't forget it. The algebra will give me a radius of plus or minus 6, but the geometry, I would only have a radius of 6, okay? Because you can't have a negative radius. But now the question is, they want a diameter. And the diameter is just twice that, so diameter is going to equal 12. This was in square centimeters, also sometimes called squentimeters. Any geometry class you took with me 10 years ago. Squentimeters. How great is that? Squentimeters? Come on. Seriously. I don't know why that hasn't caught on. But, so therefore, this diameter is measured in linear units of centimeters. Am I right? I'm right. Now, one of the things that is somewhat arbitrary, we're talking about area. We've done area before. Tomorrow, we're going to do a little bit more area. But they're going to relate this to the idea of population density, which me and my friends here in real life, we just watched a Big Ideas video, but I can't tell you where it is because it's unlisted on the YouTubes. But nonetheless, population density is this idea of density measures the how much of something fits in a space is the density, and population density is how many people can I cram in the smallest volume, or surface area in this case, I guess, yeah, why don't they measure population density three-dimensionally? Yeah. I believe every year is an annual conference in Cairo, Egypt that has the highest population density, which I'd have to go check it out. Maybe it's no longer the case. Actually, yeah, Egypt's been through a lot of turmoil in the last decade since I last taught geometry. I'm off by like order of magnitude, but it was either like 100,000 people per square mile or probably kilometer, and I don't know, or maybe it was 1 million. Who knows? But either way, the internet knows. But there's a lot of people per square unit. Population density, you just take the number of people and divide by the land. And it's usually given in terms of square miles, but can be expressed using other units, such as city blocks. That's crazy sauce. So, what if, mis amigos, what if we were finding population densities based on circles? What? Well, here, let's check out this presentation. It says about 430,000 people live in a 5-mile radius of a city's town hall. Find the population density in people per square mile. So I would just do the 430,000 divided by 5. What's that going to be? I feel like that's going to be like 86 or something. $86,000 people per mile squared. People per square mile. Which you could also just call those squiles. No, you can't. You can't. You are forbidden. How about this? A region with a 3-mile radius, has a population density of 6195. 6195. All right, so they're all jammed in there. Ouch! Ouch! Stop poking me! Ouch! Right? Find the number of people who live in that region. So the density is going to equal the people divided by the area. So let's this time I know the density, 6195, and I can calculate the area. What's that area going to be? Pi r squared, friends. Pi times 3 all squared. Not all squared, actually. I lied. Just the 3. And I want to find the population. And so I'm going to just multiply both sides by 9 pi. Oh, guys, we're going to figure out the number of people in terms of pi? Oh, I always want to measure my people in pi. Let's see, 9 times 6195. Someday someone needs to, like, take my videos and overlay, like, download them and then overlay, like, calculator punching animations of me every time I plug something in a calculator. So this is the number of people in terms of pi, but that's not a helpful number. I just multiplied this by 9. And multiply that by pi, and you'd get a population of 175,159. We'll call it 60. I'm gonna round up to 60, and we'll let people be whole people. We won't make them be less than whole. That'll be good. All right, so that's the total amount of people living in that circle. I previously knew the density, and I was able to find the number of people living in that area. So you can use that formula differently. Areas of sectors. Yes. Did I? Did I do it wrong? Oh my goodness, are you serious? That's awesomeness. 5 is 5 is definitely a radius. Wow. So that's the number of people per mile radii, is what that was. So the area would have equaled, pi times 5 squared. So 25 pi. And then, I would have plugged that in there. Yeah, so this is wrong, and I'll let the internet figure it out. Thanks for the catch. Good call. A sector of a circle is a region bounded by 2 radii. Guys, isn't radii just the coolest word? It's got 2 eyes next to each other, and it isn't the word skiing. That's the best argument right there. Man! Skiing has 3 eyes. Correct it again. Thank you. 2 adjacent eyes is what I was talking about. There's an eye in the ski... Oh, wait a minute. Man! I'm just doubting myself so much you guys could tell me anything and I'd believe it. But I trusted you, Anthony. Alright, more importantly, ski... ing. No. I just said there's an I in the first part, ski, and then there's 2 more in this. That's awesomeness. there's the first I right there. But more importantly, radii has never betrayed me. I actually don't even know if it's I believe it's pronounced radii, I'm pretty sure. So guys, area of a sector. It's going to be much the same idea, the same proportion that we had when we were measuring arc length, except instead of comparing this to a circle's circumference, I'm going to say this area should be a fractional part of the entire, like so. Let's see. Oh, I've got a hyperlink my past self gave me. Guys, this is coming in from the past, hot off the presses of the internet. Let's see what this does. Is this any good? No, it isn't. Nah, I'm not impressed. Oh, this has arc length and area calculations. Yeah, whatever. Nah, that's not helpful. Sorry, GeoGebra. You've been thumb downed. So let's put this to work. Example 3. Man, skiing. But yeah, Evan proved me wrong about the other thing, and then someone just said, Mr. Waddy, you're wrong. And I'm like, I probably am wrong. So I just was believing anything in that minute. The only thing I didn't believe in was myself. All right, here we go. Find the areas of the sectors formed by Unreal Tournament V. And let's see. So I know the radius. I know this arc. Let's find the blue one first. So the area of sector UTV, I don't even have a way, man, mathematicians, you guys needed to give me more symbols for this. I'm not going to write that out. Whoever would want to do that? That's awfulness. Area, man, I don't even... of sector UTV. Oh man, this is the worst. Okay, compare that to the area of the entire circle. What is the area of this entire circle? Pi times 8 squared, right? And that should proportionally be equal to the measure of the central angle compared to 360. So it's very similar to arc length as far as the setting up of this proportion, but instead of comparing perimeter, so to speak, of a figure, we are now proportionally comparing area, right? Same idea. You guys got it. So let's see. I'd multiply both sides by 64 pi. You got me. Actually, Jack already gave us the 64 earlier, and I just believed him. This is... Did you know that pi has 3.1459 infinitely non-repeating i's in it? No. The area of the sector UTV is going to equal 64 pi times. Let's see, what's 70 over 360 reduced to? I don't think it does very well. Those cancel out. Oh, I can cross cancel the 64 and the 36, right? Is that what you were just saying? No, that isn't, but I'm pretending you did. 8, 2, 4? 4. Yes. 4 goes into 36 9 times, and into 64 16. And I just got to do 16 times the 7, which is 70 plus 40, 102. I just did that in my head. What's up? Save the pie until the very end, man. Dessert for last. Yeah, you could multiply or deal with the other parts first. Yeah, you can. But learning how to reduce fractions is a good thing. But also, I said 102. It was 112. Which is approximately 112 times pi is 351.86 square inches. So that's the exact value. Here's the approximate value for the area of a sector. Let's see. I think we're good. Thanks for watching, internet friends. Be careful when spelling the word skiing.